Hello and welcome back to this episode of the Lambda Show. So, as I mentioned in the last episode, I started working on a compiler that I'm building out. And originally I mentioned in that video that the compiler was going to be a new implementation for Kotlin. That being said, on further thought, I realized it would be really interesting to create a new compiler that didn't just focus on Kotlin. And I talked about bringing a bunch of different language features in from different compilers and different languages that I've enjoyed over the years. But actually, I thought, why not make a compiler that is somewhat language agnostic? It could support multiple languages by simply dropping in new grammar files to that compiler and connecting it to the abstract syntax tree for that language, and then using that further connected to a common intermediate representation. This is actually somewhat similar to what Microsoft has done with the .NET framework. It's a similar concept to the idea of the JVM itself, where the JVM can, take all kinds of Java compiled languages, Java bytecode compiled languages like Scala, like Kotlin, Clojure is another example, and can run on the same VM. But what if we could actually extend this concept to support multiple languages in the same compiler and have a single common JVM based runtime that will allow you to just basically plug in these new grammars? So that's what I've started doing. Now in this episode we're not going to start focusing on supporting a bunch of different languages yet. There's more work that needs to be done around that. However, we are going to focus on integrating Kotlin first, and I'll kind of show you how I'm breaking that out and sort of what the plan is around that. So a few pieces that we need to build for this compiler. The first stage is we need to come up with a lexer and a parser. Now a lexer is effectively a tool or part of our compiler. It's the first stage that takes the actual source code text and it converts it into what are called tokens. Now what's a token? Well, basically a token is a single piece of the language. So if you have, for example, an expression like we'll take in Kotlin, val x equals 5. Each of those portions, you have val, you have x, you have an equal sign, and you have the number 5. Each of those pieces of text is a token. And so that's what our lexer does. It takes those pieces of the text and it breaks them down into individual segments that we can then operate on. Now once we have those tokens broken out, the next stage is to go ahead and parse. Now parsing is where we're taking those individual tokens and we're matching to see groups of tokens that fit into a specific pattern to represent a grammatical statement. So in the case of val x equals 5, we would say this is a grammatical statement that is called a property declaration or a variable declaration, something akin to that. Names are arbitrary here, and we can create those as arbitrarily as we want. To start with, for this grammar for supporting the Kotlin language, what I've actually done for the grammar is, rather than defining it myself, I've actually taken the Kotlin grammar that is defined already. There is a GitHub project out there called Kotlin spec. Alright, so if we want to go take a look at the Kotlin spec, let's come on over here to our GitHub page for Kotlin spec. So it's underneath the Kotlin organization, Kotlin-spec, and this repo is basically a attempt at basically defining the Kotlin language using Antlr syntax. And if you're not familiar with Antlr, it is a very popular parser generator. So what's a parser generator? You can, by the way, read more about Antlr on the Antlr.org site. That's spelled ANTLR.org. And if you're getting into Antlr, if you really want to dig into this more, this is not going to be a full-on Antlr series. Antlr is a very complex tool. But I would highly recommend, if you do want to dig more into Antlr, that you look at the Antlr book. There's this book, The Definitive Antlr for Reference. And I actually picked this book up myself, started going through it. It is indispensable for learning as much about Antlr as you can. But in a nutshell, what Antlr does is, I mentioned it's a parser generator. a parser generator. So again, taking that concept of you have your original source text, your source code text, and you're trying to convert it into a program ultimately, right? So in order to figure out what that source code is doing, you need to break it down first into tokens, as I mentioned, and then take those tokens as individual keywords and pieces of text and match those into groupings, basically. So like the val x equals 5 example, we want to take that and convert that into an assignment expression of some kind. And so we could go through and write our own Lexer and parser. It's a piece of the compiler that's going to take some time to write a decent parser and Lexer system that will handle every case and rule in the grammar. But rather than do that, we have tools already out there in the compiler world where we can just generate parsers based on rules that we set. And so that's what Antlr does. You define basically a text file and you give it a .g4 extension, and you use that text file to write these rules in sort of a DSL-styled syntax. And so if we come over here and we take a look at just what this looks like, we have a set of files here. So these files are taken directly from the Kotlin grammar that I mentioned earlier. So back on this Kotlin grammar GitHub site, we have, if you go underneath the grammar folder here, I believe it is, and you look at source, main Antlr, we have this Kotlin Lexer G4, Kotlin Parser G4, and so that's basically what I've done over here is I've copied those down into my project. And so we'll take a look here at the file, and in here we have our basic Lexer file, which we'll skip past some of these things. Again, I'm not going to get super deep into how Antlr works, but you'll notice we have these rules for tokens. So like we have write curly brace, abbreviated to rcurl, and that there is defining that this piece of text is actually what is defined as rcurl, or write curly brace. Multiplication, you have the star, modulus with mod is %sign, and so on and so forth. So these are the basic Kotlin symbols that will be broken down into, text symbols will be broken down into individual tokens. So the token name is on the left here, and then we have the actual symbol here, or the piece of text that it will match as that token. Now, once we've gotten the Lexer file here, we'll have this Kotlin Parser.g4 file, and if we take a look here, we have, for example, a function declaration which matches on these different pieces. So I can actually go in here to fun, and that's the fun keyword, as you're familiar with in Kotlin, is represented by this type. So in the parser, we're actually saying that a function declaration is the combination of these tokens together in a group, and that's what defines a function declaration. So there's a few rules in here. You'll notice we have type parameters here represented by NL, and the star here just means that we can have 0 or more type parameters specified. In this case, that would be like if you're passing in like a type of type T, capital T, typically represented as, you'd have like a left angle bracket with some type and a right angle bracket. That's what this is. We don't have to specify those on. In fact, most Kotlin functions wouldn't have those, right? So this is going to be optional. And so we put this star out here to say it could be 0 or more of these present. Same thing for receiver type, right? If we have receiver functions where we attach a function to an existing type, that's what this receiver type would be used for. The simple identifier would be the name of the function. And that could exist or not exist, because in Kotlin you can have, typically you have name functions, but you can also have functions that are not named, anonymous functions. You also have lambdas. Now this doesn't match on a lambda because the lambda is slightly different, considerably different actually, syntax from how a named function or an anonymous function works. But this particular rule here in the grammar for a function declaration is handling both named and anonymous functions. And so we have the simple identifier that is allowed 0 or more times. And then we have the value parameters, which is going to represent any parameters you pass into that function. And then we have the type. You could specify the return type that the function has. It could be unit, it could be string, integer, so on and so forth. We have and so on and so forth. We have type constraints. We have function body, which would contain the text. Now, or the text that's inside the function. Now, if we come down here, we'll notice function body is actually defined as another rule right below here. So we can have a block, and we can have an expression. Now, in Antlr syntax, the grammar syntax, we have this pipe operator, which is the or, right? It could be either a block or an expression. And I'll show you an example of what that looks like. If we look at a function spec here, an example in code, you'll notice that the case of a function where we have an equal sign, this would actually be an expression, right? So we can have two types of bodies, if you will, in Kotlin. There's the typical curly brace with a bunch of statements in there, or expressions, and then you can have just, you know, the name of the function equals and a single expression, or a single expression comprised of multiple sub-expressions. And so that's basically what this grammar is representing. Is a block would be with the curly braces around the function, and the expression here would be with the equal sign, where we assign a single expression on its own, or again with a set of sub-expressions. And so basically that's what we do to start with, right? We start off with this grammar file that defines based on the tokens that we define in our Lexer, the grammar file, which is somewhat synonymous with the parser file, basically defines the patterns of tokens or groupings of text that are going to represent these concepts in our source code. Now, once we have the parser file, both the Lexer and the grammar for Antlr, so it can generate a parser, and we say generate a parser, what it's going to do is Antlr actually takes these files, these text files I just showed you, and it creates from those DSLs a actual program. Now, what language is it used for that program? You can actually specify a few different ones. In this case, since I'm writing this compiler using Scala, we're going to generate a Java output. The current version of Antlr, version 4, which is what I'm using for this, the latest as of the time of this video, supports a few different options. Scala output directly is not one of them, neither is Kotlin. But both Scala and Kotlin can interop with Java, and so in this case I'm going to generate a Java output, a Java program. And so Antlr will take that file and it'll write a Java program for me that I can then pull into my compiler and use the source code, the Java source code for that. So let's kind of take a look at how that works. So again, coming back over here, we've got these defined, right? And you'll notice on the left, I've got these underneath my source folder. I have the main folder, as you typically have in your project. And I'm just going to collapse these here so you can see this a little bit easier. Underneath main, we have, of course, the Scala folder. If I were to write this, compiler in Kotlin, you would see a Kotlin file here, or folder here, which I'm not doing. I'm writing this in Scala. There's a number of reasons why I'm using Scala, and I might get into that at a later time, but it's not for this video. Scala, on a side note, is actually somewhat similar to Kotlin, so it's not terribly difficult to learn if you're already familiar with Kotlin. But anyway, for reasons to be discussed in a future video, I'm sticking with Scala for writing this compiler. So yes, we have the core compiler code underneath the Scala folder, and I've created a package here called Maki, the name of this compiler, and I've created these individual phases. We're not going to talk too much about phases just yet and what that means, but since we are talking initially about parsing right now, I've created this parser.kotlin folder, or package, and underneath here we have our AST package, and we have a Kotlin parser and a Kotlin visitor. Okay, so that's the basic core of the Maki compiler. Now, if we come in here to Kotlin Parser, you'll notice that I am doing a few things in here. So I'm creating some helper functions here. There's a parser function which creates the the parser and sets it up basically to be used in our project. So we have our char stream here. This parser function takes a source parameter, and then from there we generate a character stream from string, which is a built-in Antlr method that is created, and we pass the source into there. Now the next line we have, we generate our Lexer. So we initialize our Lexer from the Kotlin Lexer that was created from Antlr, and again we'll get into that in a second, but we then create our token stream. Now, the token stream basically is what we'll use to access the individual tokens that are generated by the Lexer. And then finally we come down here and we call our, we instantiate our Kotlin Parser with that token stream. Now once we have that in place, then we can start doing our parsing, which we'll get into shortly. But in order to be able to do all of this, right, we need to, so we've got our Antlr for Kotlin syntax and our Lexer tokens and our grammars for the parser defined in here. Again, you know, copied from this project here, the Kotlin spec repo. But basically once we have those in there, the next step we want to do is we'll open our Kotlin Parser.g4 file. Now, we can run this from the command line, but it's actually very convenient. IntelliJ has a plugin. And if you go search for the plugin here, let's take a look at the plugins that we have installed here. So we have the Antlr 4 grammar plugin, which is a very helpful tool if you're building a language and you're using Antlr. In IntelliJ, I highly recommend installing this. Gives support for Antlr for grammars and a bunch of features around that. One of those features, which we'll take a look at here, is if I right-click on the Kotlin Parser.g4, I have this configure Antlr option. Now, when you first open this project, or you're building a new language, a new compiler using Antlr, and you have it in IntelliJ, first thing you want to do is come down here and configure Antlr. And we can leave this option up here checked. That just means it's gonna write our Java program, parser program for us once we hit save, which is gonna happen once we hit OK here. But some of these other options we want to specify, right? So we have output directory where all output is generated. I'm gonna move this over to the side here, and basically what this directory is going to be is again looking at and actually I'm going to close this out and go over here to Java and expand that out. You'll notice we have a bunch of Java files in here. So what we're doing, if we go back to this configure dialog here, is in the output directory section, we're specifying, you'll notice the path here lines up with this Java folder. We're specifying the path to that folder, because just like if you had multiple languages in your IntelliJ project, it's exactly what we're doing here. Is we're going to have Scala, a mix of Scala, Java, and Antlr 4. So Antlr 4 grammar files, G4 files. So we just specify, all right, it's going to generate a Java program when we run the Antlr Parser Generator tool through IntelliJ, or in the command line, again, if you want to do that option. I'll probably show a command line method of doing this in future videos, but basically we pass in this Java path. The next one is the list or the location of imported grammars. So this again lines up with this folder here, right? We've got underneath main Antlr 4 at the same level as Java and Scala, and then underneath that I've created another subfolder called Kotlin, and so we just pass in that path right there, Antlr 4/Kotlin. So it's going to look for all of the imported grammars from this directory, and then it's going to output the generated Java written parser generator program, or parser program I should say. This is generating that parser for us. Now this we can leave Kotlin file encoding alone for the time being. We don't care about that right now. The package namespace for the generated code, this is completely arbitrary. You can set this up however you want. I've called it maki.kotlin, and the basic ideas here, if you look on the left, that's just again underneath the Java folder. We could put our generated parser underneath there. I'm giving it a namespace of maki.kotlin to designate that this is the this is a parser for a Lexer and a parser for the Kotlin programming language. Now, if I were just making this a Kotlin only compiler, I could leave off the Maki.Kotlin, just call it Maki, or no namespace at all, and put those files in there. But because I want this to be a multilingual compiler, I'm actually breaking those packages out by language underneath the Maki namespace. So yes, we put Maki.compiler, and you don't need to create this package. It doesn't exist. The Antlr 4 plugin will auto-generate it, or rather the Antlr 4 program will generate a folder with that namespace in it, a package for that. All right, so down here, language, you can leave this empty if you want. The default is Java. I specified Java just because, just to make it sort of explicit, in case that default ever changes. Now, it's important to note that when you put this in here, as it shows in the example, Java, Python 2, C#, you have to actually capitalize it properly with a J, uppercase J. If you do undercase, it will not work. So you need to specify the language in a case-sensitive fashion. For case transformation in the preview window, just leave that on the default, leave as is. And finally, we come down here to generate parse tree listener, which is the default, or generate parse tree visitor. In this video, I'm not going to get too much into a listener versus visitor pattern for compilers, but for now, we're going to go ahead and go with visitor. Visitor is a little more difficult to work with than the listener option. The listener option is while being easier to work with initially, is not going to provide us quite as much flexibility. And so for this compiler, I actually want to generate the visitor output instead of the listener. You could generate both if you want, and you can even mix and match those together. But we're just going to stick with visitor. That's probably the more common option in a lot of compilers these days. Definitely is what is used in the current Kotlin compiler itself. So we'll stick with the visitor pattern for now. Now, if you're not familiar with the visitor pattern, there's a number of books and websites out there you can go read up on the visitor pattern and how it works. I would highly recommend on YouTube actually looking up, there's a video by a individual named Derek Bennis. I believe I'm pronouncing that correctly. He's got a lot of awesome content and videos on YouTube. But Derek Bennis does a video on the visitor pattern and how it works. So highly recommend you check that out and take a look at that. Anyway, all that being said, once we have this together, we just click OK. And when you do that, it'll generate all of the outputs you need here. Now, just to demonstrate that this will actually work, let's go ahead and delete all of these files, right? And we'll go ahead and hit delete anyway. It doesn't matter. It's empty, right? So now we'll come down here to Kotlin Parser. We'll right click. Again, we have our options configured. If you just click OK, you'll notice that it will auto-generate. No, it didn't actually auto-generate. Let's try that again. So we have configure, and yeah, it's not auto-generating the parser, so that might be a bug in there, because it should create it underneath here. Unless it's doing underneath gen. It looks like it might be doing it underneath gen. So let's go ahead and delete those as well, just to be on the safe side. And let's go ahead and run our configure again, just to make sure. We've got Java here, Antlr for Kotlin, and click OK. It's not throwing it under gen. Okay, that must have been from a previous run. So let's go ahead and just right-click on this, and let's just do generate Antlr recognizer. So if we do that, okay, now it's running, and you'll notice here it appeared now. So it's written out the Lexer and the parser. And if you want to, you're free to open these. These are Java files. You should come in and take a look at them, but we're not really going to work at this level in the compiler. So we're not going to bother with that too much. The Kotlin Parser file, you can take a look at that if you want and see what's in there. But we won't be spending a lot of time right now on looking at that file, and we definitely will not be modifying these files. The idea is to define our grammar rules in the Kotlin Parser G4 and our Lexer rules in Kotlin Lexer G4, and just run that generate here on the parser file with those options we provided. and have that auto generate our Java program to parse, to lex and parse. So once we have those all together, we now need to import those into our program. So I'm going to collapse the Antlr 4 and Java folders because we really won't need to touch those too much in terms of modifying things down the road. But the next stage of this that we're going to start looking at is the how to import this Java program and make use of it, right? So let's close some of these out since we're getting to be a bit much here. I'm going to close the Lexer file, leave the parser file open, and we're going to actually take a look at variable declaration here and property declaration, because those are going to be the two first things to look at. So let's open up our maki.scala file here, and I can actually show you the files that were on here. So we'll have these up at the top here, these tabs visible. So maki.scala is sort of the initial entry point into our program. Now you'll notice that I'm calling print line for the Kotlin Parser.parse Lisp with args 0. This is being passed in the command line. I'll kind of explain what that is more towards the end of the episode, but basically if we go in here to our Kotlin parser, right, this is kind of where we really start to enter into the parsing itself. As I showed earlier, we've got this setup that's going on here. We basically set up our Kotlin parser with the tokens coming from the source, which is just a string that we pass in. Source just means the source code, literally. If we, again, go back to, let's look at our assignment spec here. If we go back here, so we have some source here, val x equals 5, and we want to parse that. So when we parse that, we're going to create what's called an abstract syntax tree, and we'll get into what that is exactly in a moment, but basically this is the parse function on the Kotlin parser that we were looking at earlier over here. So if we go back to parse, we call our visitor, again this is going back to the visitor pattern. I highly recommend again that you go watch that video from Derek Bennis if you are not familiar with how a visitor pattern works. But we pass, with the parse function, we pass our source into the visitor function, and then we call this AST, which stands for abstract syntax tree. And once we have that, that abstract syntax tree is going to be the internal representation in memory. It's a tree that we can represent the hierarchy of our language grammar. And so again, we'll do a little more explaining of how that kind of works a little bit in this video, but probably in a future video I'll show more in detail just the difference between parser trees, abstract syntax trees, an IR tree. There's all kinds of different trees used in compilers for different pieces of this. So anyway, we run our visitor over the source and we grab the AST from that visitor after it's generated, the AST from the source, and then we can return that. So you'll notice back in maki.scala, I'm calling the parse Lisp on function, which basically down here does a parser passing in the source, and then it calls the Kotlin file. Now, Kotlin file is the representation of the sort of all-encompassing file, if you will. So if you create like a main.kt or a hello.kt or something like that, that's what the Kotlin file would represent, is that entire file and all of the source code contained within it. And then there's this function that Antlr provides called .toStringTree, and we pass in our parser source function and parameter to that. Now let's kind of take a look at how this works here. So I'll bring up my console here, and we'll expand this text here just so you can see that a little bit better. And basically what we're going to do is we're going to run our command to compile this, right? So this is going to be SBT. SBT is a common build tool for Scala. I believe originally it was called Scala build tool, but they are very adamant now that that's not what it is. It's just SBT now. So anyway, we'll run these three tests. This is similar to Gradle if you're in the Kotlin world. SBT is commonly used for Scala. So we run our Scala tasks here for SBT. Clean, just like Gradle, it cleans the project. We're going to run a compile, which is similar to Gradle's build. And then finally we'll call assembly. Now assembly is not built into SBT. That's actually a plugin that's an SBT plugin that you can go add to your project. I'm not going to get super into that right now, but Google around about SBT assembly and you'll find resources about that. So the assembly basically task that we add on is going to auto-generate a Java jar file that we can run, but it's a standalone jar file, so we can just run that directly with a Java jar command and pass in our options to it. So we'll run this command here to compile our compiler, and this will take several seconds to run. And so now that this is finished compiling, we can actually run it with a Java jar command. And basically, we give the path here, Java jar. It goes underneath our target, Scala 2.13, Maki assembly 010 snapshot.jar. And you'll notice here at the end, I'm passing to the jar file the valx equals 5 expression. Now this could have things like, package, my program, and a bunch of other things in there, right? But we'll just keep it simple to valx equals 5. And but that's basically any expression or number of expressions would be able to go in there. So when we run this, we'll notice that it generates a Lisp output currently. This is a tree represented in Lisp syntax, showing all of the generated code that comes out of this. So you'll notice some things here. For example, we have a literal constant 5 that is defined here, and that's the 5 from here. And there's a bunch of other pieces here to wrap around each piece of this. We have simple identifier for variable declarations. This is a variable declaration, and simple identifier has an X next to it, which represents the X here. And then we have a expression disjunction. You'll notice that the variable declaration here has also an equal sign. So that equal sign is what is represented here. And so that's not particularly useful to running a program. It's parsing, which this demonstrates. But we actually want to get past there. Right? We want to generate a jar file itself. Or at least, at the very least, since we're doing this with the JVM initially, generate java.class files. We're not quite there yet with the compiler. We haven't built that portion out. But generating a Lisp output from Antlr is a good way to see that the pieces of our source code are actually being tokenized or lexed and parsed out into a tree structure to represent these different concepts. Now, Antlr does provide a way to generate trees visually. There's a grun tool that lets you do that. It comes with Antlr. And we could run that. I'll probably do another video following up on this one to explain how to run various Antlr options on the command line, including showing this tree structure instead of this text-based Lisp output as an actual visual tree diagram that you can then go take a look at, which will help with that. So in any case, that's kind of a rough overview of how the parsing will work in our new compiler. Not all compilers use Antlr, some do, some don't. I don't believe at present the Kotlin compiler itself uses Antlr, even though there is a project to have the grammar with that grammar spec, or that Kotlin spec that I showed you earlier in this episode, which is what I'm basing this on. But I don't believe the current official 1.3 version of the Kotlin compiler uses Antlr. I think it's got its own custom parser built out. I could be wrong. I'm not an expert at present on the full background of the Kotlin compiler. However, Antlr is a perfectly reasonable tool to use as an initial starting point, or entirely as a parser. And so I'm sticking with that, and if we need to modify it in the future, we will, and we'll walk through that. But that's about it, and all the time we have for in this episode of the Lambda Show. don't want to pack too much information. That was a lot of stuff to go through as it is. And again, this is kind of a high-level overview video. In the next episode, I'll start getting into how to actually interact with the parser generator itself in our compiler code, and how we can actually call the individual grammar structures like a function and extract out the details of the function, like the name of it, and the body of the function, and all of that, and how to generate an abstract syntax tree to store those details into, and why we need an abstract syntax tree. So that's all coming up in the next episode. Stay tuned, and thanks for joining me on this one.